So for those that have been following the channel for the past 6 months or so, you guys will have known that I embarked on a journey to rebuild my 3D printing enclosure setup. I recently had an old enclosure setup that was right here, housing my, at the time, just two CR10s, my CR10 V2, which I still have, and my CR10S Pro V2, which I have since sold. But since then, I have acquired more printers. I've got now an X1 Carbon, two Ender 3 V2s, and then literally just this past week, I added another X1 Carbon to my fleet here because they are literally so good. So I wanted to upgrade the enclosure to house those new printers, and then also just improve some features that I didn't really like on the previous enclosure, like the sliding doors. Now there are hinge doors on here. But in this video, I'm going to be adding a big safety feature to this enclosure that I've been wanting to add since I do print a lot of ASA polymer for all of my car projects here. So that's what I'm going to be doing in today's video, is showing you guys how I'm making this enclosure extra safe for being in and around it in the garage here. Now in the past, I did a video talking about 3D printing parts for automotive applications, and that is my main outlet for my 3D printers and what type of parts I make here at home in my garage here, is to make parts to support my C5 Corvette build, parts for my Toyota Tundra pickup truck, and just a few other things as well. So in that video I talked about the fact that for car parts, 9 times out of 10 when you do a Google search what 3D printing material to use, you're going to come up with a material called ASA, or acrylonitrile styrene acrylate. And that is because car parts, relatively speaking, have to withstand some decent temperatures. They have to be durable, hold up well to the elements, because cars are obviously parked outside for decent portions of time, etc., etc. So that is the material of choice that I've locked down to print all of my car parts from. And what I've been using pretty heavily here is this ASA from Polymaker, their Polylite ASA. Polymaker, in my opinion, makes some of the best 3D printing desktop filament out there, and their ASA is no exception to that. It's just a good quality filament that's consistent, it's reliable. I'm in no way, shape, or form sponsored by them, although Polymaker, if you see this, definitely send me some spools because I'm going through a lot of it. But yeah, I just really love this Polymaker stuff. It's been working really great on all my printers here, especially my X1 Carbon. It's amazing how fast I blow through material on this thing. It's like my printer told me that the AMS was out of material, and I was like, no way, I just loaded that. I thought that maybe there was a misload or something on the printer. Nope, turns out the spool was empty, so I'm just burning through this stuff like crazy. So with all that being said, I've been using that material pretty heavily to make parts all in and around my C5 Corvette here because of the durability, temperature, UV resistance required for a lot of those parts. Now, if you're familiar to 3D printing filament, or if you're not, ASA is basically a nicer cousin to ABS. ABS is kind of like one of the legacy 3D printing filaments along with PLA that's been around forever. ASA is kind of like the nicer cousin to ABS, where it prints a little bit easier. It's just a little bit easier to work with. It's not as prone to warping or cracking like ABS is, and it's also much better at UV resistance. But the S part of ASA, just like the S part of ABS, means that it contains styrene as part of the polymer chain or polymer chemistry. And styrene, for those that don't know, is not really good to breathe when the polymer heats up, melts, and off gases. That's why you get that weird smell from ABS as it melts. And so that's one of the many reasons why I have my printers out in the garage here. Obviously the other is space, noise, but especially for safety. I don't want any chance of breathing, you know, harmful chemicals and compounds as these printers are running. Thomas Sandelayer, if I butchered your name, I'm sorry, you did a great video on measuring off-gassing and pollutants coming from 3D printers, and ASA is pretty gnarly. So that's part of the reason why I have the printers out in my garage here, not in a living space, and also within this fully enclosed chamber or enclosure. But the last step of the puzzle is, even though they're fully enclosed here, I wanted to be able to ensure that there is no chance or very little chance of breathing any harmful off-gassing, compounds coming as the printers are running, because I do spend a decent amount of time out here in the garage. It's basically my workshop, my little man cave. I have my stationary bike over there that I do a lot of exercise on. So I'm still spending a lot of time out here, especially when the garage is closed. I want this to be as safe as possible. One of the last steps that I wanted to do as I built out this enclosure here, which I'll go ahead and turn on the lights for you guys. Now, I'm really happy with how this whole enclosure came out. It just fit together really well. I used a wireframe rack shelving, and then I got some pre-painted / coated MDF board, 1/8 inch thick, and then I used some aluminum angle here to form all my corners and be my mounting points for my hinges. And then I had some specially cut polycarbonate doors. So polycarbonate is much more durable than acrylic. Polycarbonate won't crack, or it's a lot harder to crack than acrylic. So I had that custom laser cut to fit the doors, and then I fitted some magnets to the base of the door so that way they stay shut, printed some handles, etc., etc. But what is the last major thing that I want to add to this enclosure to really kind of put the cherry on top and also add some extra safety? And that is an exhaust and ventilation system. So I basically wanted to create negative pressure within this enclosure. So when you put your hand up to this little space in the door here, you'll feel it kind of sucking air in. And that is the most safe way to ensure that there are as little harmful, compounds and VOCs coming out of this printing cabinet here. Now, with the help of ChatGPT, I did some really quick calculation on how I planned out which exhaust fan to purchase to support this size of enclosure. So I'm going to pause the video here to quickly go over the rough calculation and the process I used to size the ventilation fan for my 3D printing enclosure for this little project. Now, if you've been living under a rock and you haven't heard of ChatGPT, it's a really great AI tool for basic information gathering, some basic number crunching, etc., etc. But obviously, as it says here at the bottom, it can make mistakes, so make sure any information that is going to be highly valuable or is important, that you sanity check it through validated sources. But for a basic kind of just rough little calculation for a side project here, this is definitely acceptable. And then I also went in afterwards and Google search and found some reputable kind of HVAC websites that confirm some of this data. So basically what I did here was I prompted ChatGPT and told it the basic specifications and outline for what I'm looking to do. So it said I had ordered a fan that has a rated flow rate of 308 cubic feet per minute. And because, a lot of things you buy on Amazon come from a certain country of origin, and sometimes those specifications aren't always truly accurate, I said, assume the fan runs at 60% efficiency. So basically a little more than half of what it says it can do. And then I gave it basically the volume of my 3D printing enclosure, which is about 4 feet in length, 30 inches in depth, and I think about 55 or so inches in height when you only take into account the two printing areas. So that's all I prompted it, and it spit out this whole calculation in literally a matter of 20 seconds, which was pretty remarkable. I mean, I could have done this by hand. It would have just taken me a little bit longer to do all my, kind of unit conversions and things like that, but this was literally done in 20 seconds. So I'll just quickly go over kind of what it did. So it basically took the volume of my 3D printing enclosure and converted that from cubic inches to cubic feet, because cubic feet per minute is kind of the standard unit of measure for any type of HVAC, ventilation kind of type project. And so there it converts the cubic feet rating per minute of the fan at 60% efficiency. So very basic calculation there. So we're basically assuming about 185 cubic feet per minute that the fan is capable of moving. So what it sounds like, a standard unit that in the HVAC industry, and if you're an expert in the HVAC industry, please feel free to leave a comment below. I have very little experience, but a standard unit of measure of how well your HVAC system is up to the task is rated at what's called air changes per minute. So basically the total volume of air of whatever space that you are looking at, in this case it's the volume of our 3D printing enclosure, how many times can that volume of air be changed every minute? And so it basically just, you use your cubic feet per minute rating, divide that by the volume, and that gives you how many times basically per minute that the air in that volume of space can be changed out. And so this comes out to just a smidge over 4 air changes per minute. And so it says here for fume extraction, it's recommended to aim for 4 to 6 air changes per minute. And I did validate that through a few different websites that is in the ballpark, because I found some websites that talked about, a lot of people were concerned about air changes per minute when COVID was really at its peak and things like that. And so 4 to 6 is definitely in a safe space. And then also considering the fact of the volume, or where the fan is going to be located on the enclosure is only at the upper part of the enclosure, and it is kind of sectioned between the upper and lower cabinet. And most of my ASA printing is going to be done on the BambuLab printers, which is in the upper cabinet. So as air flows up in all the nooks and crannies from the lower shelf to the upper, but most of the air is going to be being flowed out from where the BambuLab printers are located. So our effective total volume is even less. So we should theoretically have even more air changes per minute. So I just wanted to quickly go over this because it was a pretty neat way to just kind of do a rough calculation to see if we're in the ballpark based on the fan that I had spec'd for this project. So I bought this off Amazon. It's just a standard, it's a 6-inch diameter exhaust fan used for all different kinds of purposes, all the way from small kitchens, like apartment kitchens, to bathrooms, et cetera, et cetera. And it comes with this nice dial gauge here to control the speed, and it's also the on and off switch. So I got a big 6-inch hole saw that I'm basically going to cut a giant hole in the side of the enclosure here, mount this guy up, and then I also printed a back plate. So printed this out of ASA that I'm going to use to mount from the back side or the external side on the enclosure. And then I have some flexible ducting that I'm going to route when I have the garage closed. It'll be easier to show you. I'm going to route up here above, and then there's a vent just above here for my garage, and I'll vent all of that outside just to make this thing as safe as possible. So let's go ahead and jump right into cutting out a hole on the side of the enclosure. So I'm actually going to get my X1 carbon out of the way. I'm going to be generating a little bit of dust, so I don't want to be covering this thing in all kinds of dust here. So I'm going to power this guy down, pull the power cord, set this guy off to the side. Looks like my poop chute has been partially successful, but good opportunity to clean all this stuff out of here as well. Alright, so here's my gigantic hole saw. Things got some kick to it once I hit it on the drill here. So it's got the pilot bit. I'm going to mark a little spot that I want to drill it out on the top of the enclosure here, up about here. And then we'll hit this thing to get a nice big hole cut out of this panel. Next. Alright, only generated a little bit of dust, but dang, that's a big hole. Alright, so I got the hole cut, looks good. So I had to drill another hole for the provision for the cord here. It's a clearance. So let's see how this fits. Huh. In the words of Ace Ventura, like a glove. Look at that. Professionally installed. So now I gotta drill 4 holes here for the mounting screws. And we'll put the mounting screws on along with the backing plate that goes up to the other side to butt up next to it. And then we'll get the wiring situated here, because I'm thinking I put that little dial switch probably right somewhere about here. I'll probably just drill a few holes and then zip tie it to the side here, along with some double-sided tape on the back side of the controller. So I'm gonna go ahead and throw a level on the bottom there just to make sure that we're correctly clocked to be nice and level for when I drill these holes here. Hope to get the right size drill bit. Alright, got the screws fed through on the interior face. Now I gotta put the backing plate on the outside and then thread the washers and nuts over this guy. Alright, well, after some fiddling around with the screws, I got it all firmly mounted up there. Nice and sturdy, ain't going anywhere. So now let's go ahead and get the cabling routed, get some holes drilled to put some zip ties through to mount the controller, and then get the ducting started here. So the ducting is going to go out, it's going to turn, it's flexible, it's kind of like glorified dryer ducting. It's going to go up and then follow this joist here along the top and then make a turn right there. And then I printed a mount, I'll show you guys in a bit, that will mount to the upper vent of my garage there. So, and I'll basically use zip ties to tie it all along this joist right there. Okay, so since the cabling is going to take me a minute to route and get all connected up to the main power strip on the back of the enclosure here, I thought I'd just do a quick sanity check. So I've got it hooked up with a temporary extension cord right now. So let's go ahead and fire this thing up full blast here and see how it does. So the idea is we're not creating a vacuum inside this thing. There are gaps like around the doors, in the middle of the door here, and even on the top. So it's allowing air to flow in, so it doesn't just try and create a vacuum and then surge the fan there. So, but if I put my hand up to here, if it's working right, we should feel a little bit of kind of negative pressure. And you definitely feel that. I mean, it's not like a full-on like you would feel with an HVAC system for a room, but you definitely can feel it's wanting to suck air through this channel here, even there as well. So this thing definitely flows a lot of air. This is at full blast here, and it's hard to convey this on camera, but that's a lot. That's a decent amount of airflow, way more than I had on the exhaust fan for my previous enclosure. So, and again, I'll go over the calculation that I used when kind of sizing the right fan for this, that I used ChatGPT to help me real quick. But yeah, so that's looking pretty good. Stoked to see that. And then, so I'm gonna have to figure out the cabling here. It's kind of weird. They give you a lot more cabling on this end of the controller, I guess, so that the fan could be mounted farther away, so it kind of makes sense. But I gotta figure out where I can mount this to still take advantage of all this cabling here. But likely I'm gonna need an extension cord to go from there to my power strip on the back side of the enclosure. Okay, so I routed the cable up and over. It kind of passes through the back there and then comes down on the other side. I'll probably have to use some double-sided tape to mount that controller. So you can kind of see the cable passes up through the back there. Zip tied it down so it's nice and secure, ain't gonna go anywhere. And then took the CR10 V2 out to prep for its new little kind of cart that it's going to stay on next to the enclosure here, because I'm just going to print PLA on that, so it doesn't need to be inside. And then went ahead and got this shelf all cleaned up, wiped it down, and then going to bring my current X1 that I've had and put it back here, and then my new X1 will go right here. Getting the two BambuLab X1 carbons loaded back into the enclosure here after getting most of the dust out. I've absolutely loved this first X1 carbon. I felt the need to buy a second one just as I prep for gearing up to sell more products and parts on my Etsy store for the C5 Corvette platform. These things are just such a beast of just wanting to design a part and have it printed so quickly. I had to get the Corvette backed out of the garage to get access to the area above the enclosure where I'm going to be routing the ducting, so I thought I'd just include a quick little startup blurb of the car as I backed it out, in case those that have only watched my 3D printing videos haven't seen my Corvette on the channel. But what I'm showing here is the basic supplies of what I'm going to be using to do this ducting. So I've got two sets of flexible hose, I think it's about 8 feet, and then the bracket with the adapter for mounting to the vent on top of my garage, and then basically a custom coupler piece that I designed and printed, where I'll also be putting in a small HEPA filter so that I'm filtering the air going out of the house. So I've got a little spot inside that coupler where a HEPA filter goes. So I've got the initial kind of ducting mounted onto the enclosure in that pass clip, and so now what I'm getting ready for is to mount that bracket to the garage kind of eave vent above the garage door, so that I can route the ducting up and mount it to that, and then have the two sections of flexible ducting meet in the middle where that coupler and the filter are. So I broke one of my cardinal rules here. Whenever you're drilling or putting hardware into a 3D printed part, to ream up the holes first instead of putting a screw right into it. And you'll see here in a minute that I cracked the piece as I was trying to thread in these self-tapping wood screws. Or they're technically sheet metal screws, but worked great for this as well. So yeah, so that basically split, and then I decided to just peel off that entire top of the part that was along that split where I was drilling, and it was just enough to still maintain the adapter piece for the hosing or the ducting, and so I just decided to run only 4 screws in that instead of the 5 with the piece that split off. So I could have reprinted it, but I honestly just wanted to get this done, so 4 screws it is. And this really reminded me that I need to clean out all the cobwebs and gross dead bugs that I have up on top of my garage area. But that's mounted really nice and secure to that upper eave vent. I'm really happy with that. So it'll be a great solid mounting point to send that ventilation air out. So this is the rough path that the ducting is going to follow. It's basically going to come up and then make a turn, follow along one of those joists in the garage there. Just lightly zip tied to it, nothing crazy, just because it doesn't need to be structural. And then it'll obviously connect to that piece that I just mounted to that upper eave vent. What's funny is every time I work in the garage here and I'm getting up into the rafters, it's crazy how much of a temperature difference there is just from the space below the joist to above. I mean, I was sweating a lot, even though I had a kind of a sweater on here. But here you can see the ducting mounted to that bracket that I mounted to the eave vent. So I'm just kind of getting that prepped. And then starting with some of the zip ties to kind of hold it up, because this obviously wanted to keep falling down, so it just made it was going to make for connecting the two halves together with that coupler piece where the air filter is that much easier when it's kind of held up by these zip ties. So there's kind of another shot of it running along this joist here. It's definitely not easy access. As you see here in this clip, I'm kind of like working around these joists trying to get, you know, my head in the space here so I can see what I'm doing. I tried using these hose clamps that came with the flexible ducting, but those were just not wanting to stay well on top of and keep the ducting connected to the coupler. It could have been a design thing on my end, so I ended up just zip tying the flexible ducting to the coupler and then zip tying the whole thing to the joist there. And I was trying to get this done quickly because I had limited time with my son kind of getting to the end of his nap cycle during the day, so I just needed to get this done quick. So I'm probably going to come back in and kind of clean up some of these zip ties and make them look a little bit prettier, because this is going to be here to stay for a while. So this is the final flow path. So it kind of comes up, makes a turn, goes over that little joist connector piece, and then makes one more turn to go out that eave ducting. And the nice thing is, if I ever need to move my enclosure, because my enclosure is on caster wheels, all I have to do is unconnect one hose clamp on the enclosure part, and then you can see here, this is where it's venting out on that eave duct. So hard to show on camera, but it's flowing a lot of air out of that little piece there, so kind of a great confirmation that we don't have any major restrictions in our flow path on that ducting coming out. Okay, so one last little look at the exhaust fan setup now that everything is pretty much all wrapped up. Thought I'd try and give just a little unofficial, non-scientific visual way of showing the flow out of the enclosure on this side. So with a little dryer sheet there, and just throwing it up, you can see it's definitely drawing some decent volume of air out of the enclosure here. But yeah, that's going to do it, everyone. Just wanted to do this video to show you this setup, and it has definitely worked really well. I've been using this over the past few weeks here when I've been printing. I was running a lot of PLA for a project in my toolbox, you can see there on the left recently, and the garage is starting to smell kind of like PLA. PLA is a lot safer of a material, but it still kind of smelled like that hot, sweet plastic smell. And within a few minutes of turning this fan on, the smell was completely gone in the garage. So another confirmation of how well it works. But yeah, so I hope you guys enjoyed this video. If you have any comments or questions, feel free to leave them below, and I'll do my best to answer them for you. Hope you enjoyed the content, and other than that, guys, I will see you in the next one.